Hello, this is Rahul. In this lectures, we are going to learn disadvantages of distance vector algorithms, which is RIP protocols. In distance vector algorithms, there is a big problems with count to infinity problems. This is very important. Most of when the algorithm is being asked in exams, then generally they ask questions related to count to infinity problems. Due to count to infinity problems, the slow convergence slow convergence happens. What slow convergence means? The stabilities on forwarding tables or the vectors takes time. So what count infinity problem is, we will see in details. Suppose we have a network. This is a network and this is a router R1, R2, R3. R1 is directly connected with this network N. So that we have the forwarding tables or vector on each routers. You can verify yourself. This is if it all verify for R1. R1 to R1 is 0. R1 to R2, this is 1. R1 to R3, this is 2. R1 is directly connected with N. So that's why this is 1. Right? I hope this is clear. So count infinity problems occurs when there is a physically changed happens, means disconnections of network or disconnection of link. Suppose N is a network B has been disconnected with R1. What happened? So R1 quickly changes the entries corresponding to network N to infinity. So this is okay one. Infinity means this network being disconnected. But R2 doesn't know what are the changes being happened and what are the disconnections, because R1 has not immediately sent the vector to R2. What if R1 received vector first from R2? What it means, R1 will understand, oh yeah, R2 has entry corresponding to N, which is 2. What it means, R2 can reach to network N by a cost 2. So if R1 think like that, then R1 make change its vectors, like from R1 to R2 is a cost 1. Then R1 to R2 to sorry. From R1 to R2 cost is 2. From R2 to Rn is cost 2. So that's why 1 plus 2, the cost would become 3, corresponding to what? 1. So what if in next cycle of operations, if R1 sends its vector to R2, what happens? R2 thinks there has been any change in network. In that case, the R2 makes change in its vectors, which is 3 plus cost of reaching from R2 to R1. Now from R1 to Rn, that is 3, it would become 4, 3 plus 1, 4. And next cycle, what can be happens? If R2 sent again back to the R1 routers, then this value get increased by 1. This happened until these values reach to infinity. These all values go corresponding to both routers. We will at any point of times they will reach to the infinity. But this process could have happened within some milliseconds. I mean in constant time. But this process is iterative. So that is the reason sometimes the process takes time. That is the meaning where we have it was written slow convergence. So can we have a strategy to solve these problems? First one is strategy is split horizons. What is split horizons means? If B has learned from A, then B will not send its vector to A. This is very simple one. And can we achieve this one by changing in vectors? Yes, we can achieve this one with what we call Poisson reverse. Suppose A has learned from B, then router A, the vectors we made will make change corresponding to B infinity, because we have learned from B. So we will not we will not make any changes from B to A. So that's why we have made entry infinity, right? It's prevent to updates the updates back from the reverse. I hope this is clear. Thank you.